Hello all, hope all you are fine. So this is Mithun Raj from this part of the world, and this is the second part of the video we already completed yesterday. Okay, what was the chapter's name? Of course you can see behind me, it is chemical reactions and equation. It is the first chapter from your science chemistry for 10th standard. So let us do a quick revision, just 2 minutes quick revision what we already finished last day. Come on. Anyway, chemical reactions and equation. At the beginning you studied about physical and chemical change. Physical change and chemical change you already studied that in the past year. So example for a physical change means yes, it is of course that water changes to ice when it freezes, and when we heat the water it boils and becomes water vapor. Only the physical change is changed. Okay, but in this chapter we don't want to deal anything about physical change, because the name of the chapter is what? Chemical reactions. Understand? Chemical reaction, where a process in which new substances are formed. Understand? The entire physical change, let's leave it. Chemical reaction means something new is formed, and in most of the cases we cannot bring back that substance into the original form of matter. That is called as a chemical reaction. In the first part we went through an example, burning a magnesium ribbon. Okay, a simple magnesium ribbon, if we burn in the presence of heat, if we are applying heat, it will react with oxygen in room temperature and it will give magnesium oxide. Okay, the solid form with gaseous form will give another solid form. So this magnesium oxide we cannot change it back to magnesium. That way it is called as chemical reaction. Okay, that's the thing. And after that we went to a small part regarding these equations. This is about zinc granules. If we put zinc, small pieces of zinc into hydrochloric acid, what will happen? It will form zinc chloride and hydrogen gas will evolve. Understand? And hydrogen gas will evolve. With the same time it will produce some heat. It is another type of chemical reaction we studied last day. So two more portions are remaining in this chapter. One is about this balancing the equation, and the second part is about different types of reactions. What are the basic types of reactions? We will go through that different types of reaction in the next video now. But this part which is balancing the equation, it is very important for you chemistry students. Many students already complained me that it seems very difficult by seeing that big reactions and all. Just have some in my book, just see. Confused, totally confused. See the length of that reaction. Can you see that? Hold more. See the length of that reaction. By seeing that, most of the students, they are out of their mind. Oh my God, what is this? It's a long process. How am I supposed to do that? But today we will follow two different styles, two different methods to solve it. Okay, one method is a common method which is in our NCERT textbook. Okay, that is a basic method for all the students. The students must follow that method. But there is one more method is there. It is not mentioned in our textbook. But after completing the first method, we will go through that second method. It's a special secret method. Okay, don't tell anybody. It's a secret between me and you. Okay, whatever method you likes it more easy, you can continue with that method. No problem with that. Okay. Anyway, the answer must be correct. Balancing the equation, the last equation we are getting, if the answer is correct means you will get full marks. This balancing equation, sometimes it comes for 2 marks, sometimes it comes for 3 marks. 3 easy marks. Understand? Maybe after this class, I am sure that almost all the students who are watching this video will be able to solve chemical equations very easily. Actually, it is nothing, it's a lots of formulas, but it is connected to each other. So before going for starting the balancing of equation, we need to go through some basics about that. So the first one is about what is a symbol and what are formulas? Anyway, you know, equations, it's a combination of symbols and formulas. So in chemistry, almost all elements, they have a symbol. I told this in last class that if you are using that one word called as what? Hydrogen or oxygen. If you want to repeat that 100 times in a paragraph, it is easy or it is difficult to do that. That's why the scientists come with an answer to that. They use these symbols. For example, Fe stands for what? Of course it is iron. Al is aluminium. C, you already know, carbon. O, oxygen, what we breathe. Hydrogen. Copper, cuprum, copper. So these are the basic symbol of an element. Okay, the basic method to describe an element in symbolic form, that is called as symbols. But lots of other compounds are also there in the atmosphere, in the earth's surface and in the world. For that, example is CO2 carbon dioxide, H2O, water, CO, carbon monoxide. There is no doubt about that. It's a basic formulas. Okay, these are called as formulas. That means two or more atoms are there. Two or more elements will form these formulas. And chemical reaction is nothing, or chemical equation is nothing. It's a combination of symbols and formulas. Understand? And one more thing is this. First of all, when we are dealing with chemical equations, the first thing we want to do is to understand these symbols and formulas. So, in 10th standard science or chemistry, we are dealing with only a few types of equations, and most of the equations you are very familiar with. You know that is carbon dioxide is CO2, H2O is water, CO is carbon monoxide, like that. Lots of H2SO4 is sulfuric acid, HCl is hydrochloric acid, like that. It's a very base only we are studying in this chapter. So first of all, when we want to balance, a question will come in our mind. What is the need of this balance? What is the need? So last class we discussed that Lavoisier, a chemist, he already discovered that during a chemical reaction, the number of atoms is mass. Mass of reactants must be equal to mass of the products. Let us take it here. Can I remove this? I think you are very familiar with these equations and all, physical chemical change. We can take it off, no need of this anyway. We need some room in our board. So I am going to take this one, and also I will remove which okay, you already finished with that. That also we can take. Anyway, one more time we are going to solve the same equations. This is very easy equations. That way, to the first time, if you want to understand it, you must go through this. Let me see. Okay, it's a simple magnesium ribbon burning in the presence of oxygen to give magnesium oxide. Okay, this is also apart from that. Okay, zinc and shares. Okay, that also yes me. Okay. So another thing is this one. It's another formula. Okay. This is that number of atoms. Number of atoms of reactants must be equal to number of atoms of products. Reactants comes in which side? Isn't it? Products. Every time. Wherever you are in Germany, you are in Japan, you are in America, you are in India, you are in Canada, you are at home. This rule is universal law of chemistry. Reactants, every time it comes where? It comes the left side, and the products what we are getting, it comes the right side. Okay? Or what? All chemical reactions you are seeing in this world, this rule will be constant. And how we can find out these reactants and products? There is a special symbol like this one. Okay, it's an arrow mark. An arrow mark separates products and reactants. Understand? There will be one reactant, there will be two reactants, there will be multiple reactants during a chemical process. But wherever you see an arrow mark between that equation, after that, which will come? it will products. In products also there will be multiple products. One product will be there, 10 products will be there. In the case of hydrogen plus oxygen gives water. Only one product is there. Two reactants are there. Anyway, we will go with lots of equation so that we can solve it very easily. So the number of atoms means nothing but mass of that particular thing. So the mass of the reactants and the mass of the products is a constant, isn't it? Mass of the, for example, if you add, just imagine that you have 1 kg of tomatoes and half kg of potatoes. Isn't it? You have 1 kg of tomato and 1 kg of potatoes, and you are mixing these potatoes and tomatoes together. After that, you got a mixture of potatoes and tomatoes. If you weigh that mixture and if you weigh that reactants, here we use tomatoes and potatoes, what will be the weight? It's the same. 1 kg of potato, 1 kg of tomato. Here we mixed it together. Yes, of course, it's a common sense thing. The weight must be constant. Here 1.5 kg total, here also 1.5 kg total. That is the same thing we want to see while we are balancing the equation. Not balancing the equation, writing an equation in chemistry. See, here what are things we got? We have a magnesium plus oxygen will gives us magnesium oxide. So as per Lavoisier's theorem, this reactants and products mass must be equal. Let's see. Here how many atoms are there? Magnesium, how many atoms? Let me fetch my marker. Magnesium, only 1. Isn't it? There is no. If there is nothing written here means it's automatically 1. 1 into any other number gives the same number. Mg into 1 is 1. Oxygen, but there is 2. The total, how many atoms are here? 3. Magnesium here again, 1. No problem. Oxygen again. Where is the other? Oxygen also is 1. Oh, where is the other oxygen gone? Even for a movie? Who knows? But according to Lavoisier's theorem, the number of atoms of the reactants must be equal to the number of atoms of the products. But this particular chemical equation won't satisfy that. So what we want to do? So we want to make it balanced. Okay? We want to make it balanced. I will remove this one also. This one I think you already know about symbols and formulae. I think you studied it in 8th or 9th standard, isn't it? So the main part, the main heading we are going to deal is balancing the chemical equations. So we need to balance the equation. This is what type of equation? Balanced equation or skeletal equation? You studied in last class. Come on, fast. Balanced. Skeletal, of course, is correct. Skeletal equations means the number of atoms of reactants and products won't be same. So let us try to balance this equation. It's a very common technique. Okay, very common technique. What we want to do? We want to add how many atoms are short here, that much atoms we want to add at this side. And if the shortage is there means we can add in this part. So while we are balancing an equation, you want to keep in mind, okay, these small numbers, these small numbers we are writing, we cannot change that. Understand? We cannot change that. And we need to add only whole numbers. We cannot add 0. Understand? That's impossible regarding chemistry to add, multiply something with 0. 0 into Mg gives 0. There is no reaction there. 0 plus oxygen gives only oxygen. There is no reaction there. But we need to multiply these each elements with whole numbers to balance the equation. So in this case, Mg is 1. Here also Mg is 1. Mg is balanced, empathetic. But in the case of oxygen, here 2 is there. Here only 1. So what we want to do? We want to multiply this one oxygen with 2. So 1 into 2 gives 2 oxygen. But see, oxygen is 2, here also oxygen is 2. But one problem is there. How we can multiply only oxygen here? Because it's a mixture. It's a powdered, it's in a powdered form. Can you take each oxygen from that and you can multiply that? No, it's not possible. So we need to multiply the entire MgO. Understand? So we have to multiply Mg also with 2. So then it becomes what? Mg plus O2 gives us what? 2 MgO. 2 MgO. Okay? Balance, right? Mg1, oxygen, 2 Mg. Mg2. Is it balanced? Again, get confused, right? See. But here oxygen also find 2. 2 into 0, 2 into oxygen, 2 oxygens, 2 Mg is 2. I am writing the number of elements at the number of atoms at the bottom of that equations. So what do we want to do here? It is a single element. Okay, if you can multiply it by 2, 3, 4, there is nothing will happen to this oxygen. Okay, there are 2 different elements. So what do we want to do? Into 2, which gives 2 Mg plus O2 gives 2 MgO. Now it is balanced. Just check. We can check it. Mg. How many? 2. Oxygen. Order 2. Here 2 Mg. 2 O2. 2. It is balanced. I will say it is balanced equation. Understood? Is it difficult or easy? Okay, you can comment with that group if it is difficult or easy. At first it seems to a bit weird to you because the first time you are dealing with balancing the equation. And one more thing I will say, it is a very simple equation. Okay, it's a very simple equation. You are going through these types of equations. Maybe we will try it after this class. I hope you will be able to solve all these equations very easily. Okay, next one will be another. This is a common equation which deals with only 2 or 3, only 2 elements. Only Mg and oxygen is there. So let it make a bit more difficult for you. We can make it a bit more difficult. Come on. See, I have some zinc here. I have some chlorine. I have some hydrogen. So what is happening here? Let us start. First, what we want to do? First, we want to find out the number of atoms in each of these elements, and we want 2 methods are there. We can write in the bottom, or you can make it a column here. Okay, just like a column, we can write that. In the textbook it is mentioned like that, but it's like this also. If you write means it is correct. Zinc, how many? 1. Hydrogen, 1. Chlorine, 1. Zinc again, 1. Here chlorine, 2. Hydrogen also, 2. So there is a confusion. Which element you want to balance first? So in the case of chemical equations, go for the compound or an element which has the maximum mass. Understand? Maximum number of atoms is there. Go for that particular compound or substance first. So here, which has the maximum mass? Here only 1, here only 2, here 3. So first we want to balance this one with this side. So let's see, zinc 1, 1. There is no need of any balancing, it is equal. But chlorine here is Cl2, that means 2. Here is only 1. So what do we want to do? Into 2. If you are multiplying chlorine with 2, we need to multiply hydrogen also with 2 because it is a it's a simple compound, is it? Hydrogen chloride or hydrochloric acid. It's a one matter. So we need to multiply 2 with hydrogen also. Then what it will become? 2 HCl, am I right? Is it correct or not? Hydrogen plus 2 HCl gives Cl2 plus H2. This part is balanced, zinc 1 1 balanced, hydrogen 2, chlorine 2, that is also balanced, isn't it? So how we can write the equation at the final time? Let us see, it is balanced or not after that. Zinc plus 2HCl, 2HCl will give us what? Zinc chloride plus H2. Is it balanced? We can count how many elements, how many atoms are there on the left side. Here zinc 1, hydrogen 2, chlorine 2. That means 1 plus 2 gives total of 5. Okay. So the reactant side has 5 atoms. Let me count. Zinc 1, chlorine 2, hydrogen 2. 2 plus 2, 4 plus 1, 5. Product side is 5. Is it balanced? Is it easy? So it is easy. Okay. Any doubts? Any doubts means you can comment in the WhatsApp group. So school is providing for you. So this is also, I will tell it is an easy equation to solve. Let us make it more difficult. Come on. Carefully, listen carefully. This will be more important. Where is my equations? Okay, this one. You want to go for this? It's an easy one. Or you want to go for this one? For this, I think there is no time. So today we will discuss about this one and we will finish it. Okay. Come on. Yes. We'll tell it is simple, am I right? Easy, very easy.